Hi, my name is Jay Clifford and I'm a developer advocate here at InfluxData, and I'm also one of the maintainers and contributors to the new 3.0 Python client library. So for this developer short, I thought I'd take you through an introduction to the client library, tell you about some of the internal features, and give you a demo to see how you can get started utilizing it. We'd also like to see some contributors, so if you feel like contributing to the library, your pull requests will always be accepted. So to help us learn about the client library today, I thought I'd come up with a fun demo using Pokemon trainers. So the idea about this demo is essentially we'll monitor the number of catches trainers have throughout the day. We'll then be able to separate by, the class of Pokemon, how many they've collected on a specific type, and be able to compare them across the board. And we'll use other Python libraries such as Plotly and Pandas to help us with this. So before we get to this exciting demo, what I first wanted to do was give you a bit of background on the new client library. So the purpose of the new client library was to really go back to our roots of being a community-driven client library for InfluxDB. The other purpose that we wanted to do was also make a very lightweight library, basically just to be the ability to write and query. And this led us to the following features. We obviously have writing available to us. We have writing from files, so being able to pass from files. We have querying and being able to translate those queries. And then we also have the ability to translate the data returned using Apache Arrow utilities and other serialization tools such as Pandas data frame. What it's not is a database administration tool. We're compiling those into a different tool set within InfluxDB, and it's not a replacement for the V1 and V2 client libraries, which you'll understand in a little bit more when we talk about the query functionality. So if you look on the right-hand side of the screen, you can see kind of how the structure of the project works. We have this class called InfluxDB client3, which is our class you initialize with all of your parameters. And then you have a series of functions available to you: write, query, and write file. So write is extremely similar to the V2. Actually, funny enough, it is very much like the V2 client library because it is. So bundled underneath, you have the ability to use the V2 write API. You have batching, data frame conversion. You have the ability to construct point objects. You can also even create raw line protocol. And you can also convert from different Python specific data structures like a PyDictionary as well and write those to InfluxDB. Now, querying, this is where a lot of the heavy lifting is being done to make way for the new InfluxDB 3.0. So querying is now based on a new protocol called Apache Arrow Flight. So essentially what this offers is PyArrow support. It also offers basically near native Pandas support, data streaming for large quantities of data. We'll talk about that more at the end, and the ability to serialize into different Python objects with basically no overhead. This is all thanks to basically PyArrow and the underlying Arrow memory format. And lastly, just as an additional feature that we added was write_file. So this allows you to pass different file formats and then write them to InfluxDB, which also leverages the PyArrow library to do this. So you can pass JSON, Parquet, Awk, Feather, and CSV. So why Apache Flight? So why are we not using the standard sort of like REST or HTTP endpoint anymore? Well, InfluxDB 3.0 is now based on three core new columnar technologies, which is Apache Parquet, Apache Arrow, and Apache Data Fusion. Apache Data Fusion, which is our query scheduler, enables us to use an Arrow Flight endpoint. The benefit of this is an extremely highly performant data transportation framework that enables data to be columnar data to be transferred in a columnar format. So one of the main benefits of doing this is it's great for distributed computing analytics. Of course, you get that high volume data transfer, so you get lots of data back, so it's great for machine learning tasks. For us specifically at for InfluxDB 3.0, it gives us a way of offering both native SQL and InfluxQL support through one endpoint. And it also returns that columnar format, as I've said before, which gives us the ability to directly convert into things like pandas data frames really easily, with little overhead on your client-side application. So now that we've done a little bit of background on what the Python client library is in 3.0, let's talk about this in practice and how you can get it installed and running on your system. So first talk about installation. I always recommend starting with a Python virtual environment. No matter what library that you're using, it's safer to do so, and you can keep all your pip installs in check. So make sure that you do that first and keep your pip install upgraded. Next, you can install via pip your InfluxDB free-Python, which is the new client library. Now, there are certain features such as the write file and the pandas conversion that do require pandas. So you can either install pandas directly with just a pip install pandas, or you can install it as an optional package like this where we do pip install InfluxDB free-Python square brackets with pandas, and that will also automatically install pandas for you. Now, as we said, it's a very lightweight library, so we really wanted to keep the core code simple for you to be able to use. And so what it really breaks down into is library import, initialization, write, and query. So what you'll be able to see here is in the library import, you basically include the core class, which is the InfluxDB client free, and then you can include a series of other objects such as the point object that you'll be familiar with from V2. With these, you can find a list of all these within the documentation on the GitHub page, and also in an upcoming InfluxDB University course. Next is initialization. So this is where we put our core parameters, our core security parameters, and the URLs and the databases that we want to connect to. So we can establish our host, our organization. Now, organization is only required for InfluxDB serverless. If you're using dedicated, this can be completely removed. It's an optional value. Your token, which is your authentication to write and query, and then the database that you would like to write and query from. Now, when we establish an InfluxDB free client, which you can see here, you can just establish a token, host, and org. If you'd like to, you can also include your database here, and then the database will be inherited by the write function and by the query function, so you don't need to specify them throughout. It really depends how you want to code, whether you want to have a client per database connection, or you just want to use one client and connect and drag data from lots of different databases at one time. The next thing that you'll probably be doing is writing some data into InfluxDB. Now, if you're not using Telegraph and you want to write it with the Python client library, as we said, you can write basically using a series of V2 functionality. So in this case, we're using the point object to essentially create a measurement, a tag, and a few fields, and then a timestamp on the end. And then we simply do client.write, and we can write that data into InfluxDB. On this case, we would also need to include our database, which would be on there on the end. Lastly, what we need to do is we need to actually query our data back out. So essentially what you're going to do here is you're basically going to go define a string literal, which would be your query. And then what we're going to be able to do is call client.query. So you can basically say, give me my query here as a parameter. You choose what language your query is in, whether your query is in SQL or InfluxQL. And then you choose the mode. So the mode's really interesting, and I'll discuss a little bit more about that in the demo, but it essentially allows you to decide how you want your data returned. When we use the mode all in this case, we return a pi-arrow table. So what exactly is a pi-arrow table? Well, a pi-arrow table is the Python representation of the in-memory arrow format. Now, I won't dive directly into this because we could be here all day talking about Apache Arrow, but all you need to know is it's a language-agnostic, highly performant way of representing columnar data in memory, and it's extremely efficient for our modern day CPUs and GPUs. So you can basically see the traditional buffer memory way of saving a table like this, which is by basically row by row. In arrow memory buffer format, you can see that we save each column in this way, and we iterate through each column. So really what you need to understand is there's actually a bunch of utility function that we can use in the PyArrow library itself. So one of the primary things that you'll be doing, especially if you're a Power Python user, is probably converting your data to pandas data frames. So that's extremely trivial when it comes to converting from that arrow table. Essentially, you just take that table and do 2_pandas, and that will convert from the PyArrow format with little overhead into a pandas data frame. And then you can then perform all the normal functionality you would with a pandas data frame. You'll see some more of that in the demo. So other things that we can do while it's still in arrow format, and we actually use some of these under the hood, is that you can actually write your PyArrow data to different file formats such as Parquet, JSON, CSV. So in this case, what you can do is write your data to a Parquet format. You could then even read your data back in. So this is really great if you want to save some of your data client side and then hot load it back in. And then even you have some more powerful features to basically perform and transform your data while it's in PyArrow, that PyArrow table format. So you can perform some aggregations upon your data. So you can basically group by a certain column, and then you can find out the mean, max, and min before you even convert to a pandas data frame. So it's an extremely efficient way of transforming your data. So that's a lot of the theory done. We're going to jump into the demo now and basically take you through some more of the advanced features of utilizing the new Python client library. So on to the demo. So here is my Pokemon cookbook. What this really is a Jupyter notebook, and this is how I'm going to take you through basically monitoring these Pokemon trainers using the new InfluxDB Python client library. So essentially what we're going to do is we're going to call a number of functions or packages that we need, as we saw based on that other example I showed you in the slides. We quickly click play here to initialize them. We're then going to use a bit more of an advanced feature of the V2 API, which is basically establishing batching. So in this case, we're creating a batching callback object. This allows us to basically return success, error, or retry if there's been failed writes to InfluxDB. We're then going to define a series of parameters within our write_options. This is the ability to basically govern how you batch and write your data using that write API. So we're going to batch in size is 100. We're going to have a flush interval of basically when we want to make sure we write those out by. So that is, we're going to make sure that they're written out within 10 milliseconds. Jitter is basically so we can basically randomize when these get jittered, these samples get sent out. The number of times that you want to retry, and the delay between retries as well, which is great for intermittent network connectivity. So we bundle these all together in the right client options. You can see the right options there, along with those calls to those functions for the success callback, error callback, etc. So we're going to initialize these functions and these parameters now. The next thing that we're going to do is we're going to establish our InfluxDB client. So you can see here I've created my token, my host, my org. I've also provided the database up front. And I've also asked that the data be written to InfluxDB using gzip compression. And then I've also provided those write client options as well. In this case, I've also said, give me a timestamp for now, and basically set up a bunch of parameters, which include my trainer, the Pokemon CSV that contains our Pokemon codex, basically. And then the number of entries that I want to create, so the number of catched Pokemon. So if I quickly press play on this as well. Let's start by generating some data. So let's generate those 1,000 entries. And you can see this is kind of how the structure is made up for each of those entries. So as you can see, we now have a pandas table, which contains a timestamp, the trainer, and number of catches, including their name, their level, attack, defense, HP, and their type. So now that we've created this pandas data frame, let's write this pandas data frame directly into InfluxDB 3.0. To do this, we simply call our write function. We then provide the pandas data frame, a name for the measurements that we want to write to, so the table basically, and then a number of columns that we want to make tags. So just remember in InfluxDB, the tags are part of our primary key and allow us to differentiate between different items with the same tag, same timestamp. The sleep here is just to make sure, since the batches are running asynchronously, that our Jupyter Notebook doesn't basically stop before the batches are written. So as you can see here, we've written our batching successfully. We wrote that data to InfluxDB. Let's now query that data back out. So we're going to use Plotly to visualize our data. But first, what we're going to do is we're actually going to establish a query to show that we actually have columns and what columns we have available to us in our schema. So in this case, I'm going to show columns for court. This court here is basically the table that contains all of our catches, all of those Pokemon. We're then going to put that query into basically call that dot query. We're then going to query, we're going to provide the language because it's a SQL-based function. And then we're going to say mode is pandas, so we want to return a pandas data frame back to us. And then we're going to display that table. So as you can see here, we have 11 columns, each with different data types based on the representation that we ingested with that pandas data frame. Right, so now that we know our schema, let's take our schema and then run a simple InfluxQL query. So now you notice that we can actually just provide an InfluxQL literal query and then just change the language to InfluxQL in order to be able to adopt it. So in this case, what I want to do is basically count the number of Pokemon grouped by trainer from the last hour. So we'll see how many Pokemon each trainer has caught. And then what we're going to do is simply provide that data frame that we get back from our query to Plotly, which is our visualization tool, and then we're going to generate that into a bar chart. So as you can see here, we have all of our catches for the different trainers that have caught the Pokemon. Okay, so that was quite a trivial one. Let's sort of up the ante a bit and let's add another group. So basically what we want to do is we want to group by trainer, but we also want to group by the type of Pokemon as well. So essentially we're doing exactly the same again. We're just providing a type on the end of the group by for the last hour. And then we're going to generate that as another bar chart. So as you can see here, this is our query come back through, grouped by trainer, but also grouped by our type as well. So you can see Gary's doing very well with water-based Pokemon. Okay, moving on from there, let's talk about working with arrow tables. So basically what we've done is we've queried a lot of the time and brought it straight back in as a pandas data frame. But why don't we bring it back in as a raw arrow table and see what we can do with it? So to do this, what I'm going to do first is generate a lot more data just to keep it interesting. So essentially what we're going to do here is we're going to provide like a delta to this data, and it's going to provide a lot more data over a course of a period of time. So we're just going to let this run through and write the data to InfluxDB. Like so. And then we're going to then query that data back out. So in this case, what we're going to do is we're just going to basically say select stars, so select all columns ordered by time in InfluxQL, but with the mode all. So this will return a pie arrow table. So we're going to print this arrow table so you can see it. And then we're going to then show you how we can aggregate that data using pie arrow. Now the interesting thing here is that it's going to generate exactly the same bar chart as the one we saw before that we did as an InfluxQL query. But what I'm doing this time is doing the aggregation on the client side. So this is really important. Basically, if you want to bring all of your data back to your client application, you want to keep it in its original structure. So you want to know what the raw data looks like, but then you want to provide efficient aggregations client side. So here we go. So we basically do this. We bring back our query. You can see this is what our pie arrow data structure looks like. We basically get all the different types and what the data looks like. So this is basically just a text written version of the PyArrow table. And if I scroll down, you can basically see all of the results based on the group by, so the number of people and what's been written. So obviously the results can be slightly different from our last table because we added a lot more data, a lot more captures to the overall collection. So as well as that, we can also save our raw table file to, say, something like a Parquet file for later usage. So let's do that. So simply all we need to do is we need to include the PyArrow Parquet package. And then all we need to do is do pq.write-table, include our PyArrow table and a name for the Parquet file. We click save, and that writes our Parquet file to file. And you can see that there. So next thing we can do, basically doing this, we can showcase another feature of the InfluxDB client library, which is basically converting a Parquet file and writing that into InfluxDB. So you can see that we basically take our InfluxDB free client, we call write_file, we provide the name of that Parquet file we just created. We're going to send it to a new measurement table. The cool thing here is though, if you have a measurement name or column in that Parquet file already, you don't need to specify measurement name. The function will just automatically pick that up and write that to that measurement specifically in InfluxDB. We're going to specify the database here just so that you can manually specify the database. We're going to say which column is the time column, and then we're going to provide which columns are considered tags again. And as you can see, we're writing that data directly to InfluxDB. So just to prove that we've actually wrote that Parquet file to InfluxDB, we're going to query it back out again. So as you can see, since we wrote that data to measurement 2, we're going to do exactly the same again when we do a select count from Canto 2, where time is now -1 hour. But instead of basically grouping to make a bar chart, we're going to make a line graph because we're going to group in time-minute intervals. So we're basically going to take a count every 10 minutes to see what the progress is of the trainers. So as you can see here, this is basically a line graph over time of the number of captures for each trainer in 10-minute aggregations for the last hour. So you can see the number of captures as they go through. So this kind of gives you a basic understanding of some of the more advanced features of the client library, but also sort of the basic features as well. What I'm going to jump back to now is I'm going to give you a top tip for looking at another advanced querying feature that's not shown in this demo. So my top tip is to consider another mode when you're dealing with large quantities of data. So if you're dealing with data, say over 1 million rows, one of my best advice is to basically use chunk mode. So chunk mode essentially creates a flight streamer. And what that will do is basically provide the data back to you in an iterative format. So essentially you get back batches of your data rather than all of your data in one table format. So you could say, okay, give me the next 10,000 rows of that data, and you'll iterate through until you've completed your query. So there's not much change to the code. You're simply establishing your mode as chunk. The biggest clinch here is that you need to provide this batch buff. And then essentially what you're doing is you're asking the reader to provide the next readable chunk to you. Make sure you add a try and accept clause around it, because this stop iteration will trigger the moment there's no data left to be collected from InfluxDB 3.0. So a great top tip, especially dealing with lots and lots of data in InfluxDB 3.0. So I really hope you enjoyed this developer short. Well, maybe not quite a developer short. It was a little bit longer than expected. But I really recommend that you try it out yourself. You can scan the QR code to basically access InfluxDB free-Python, or you can search it on our Influx community GitHub page. I'd love to see your contributions there and see what you get up to. And like I said, all your pull requests will be accepted once we've discussed them via issues. Thank you now, and have a great day.